Welcome back, dear students. We are here with a new lecture series for pulse radar. So, in the previous session, we have discussed what is a radar. Radar is a equipment which is used to measure the range, bearing, elevation, speed of different targets at far position which is not visible by our mere eyes. So here I am presenting a new topic, that is the pulse radar. That means the radar which functions on the basis of transmission and reception of small short time pulses. So this session we will cover the pulse radar fundamentals, its block diagram, operation and its application. So let's start our session. So this is a good view, I hope so. This is the radar, that is a target or object which is present at a far position. We need to measure its parameters, and to measure its parameters we need to transmit some electromagnetic pulses. So these pulses will be transmitted by my antenna. That pulse will travel in space to the object and it will be reflected back towards the antenna. That reflection signal will be processed by the antenna, and finally the processed output will be analyzed to derive the different parameters. So let's see how this process is being done in a pulse radar. So this is the block level concept. This is a simplified block diagram. As it is a very complex circuit, I have tried to minimize the blocks so that it could be easily understood by you all. So as we know, in case of any communication system, we are having a transmitter section and a receiver section. So here we are having two sections. So this section is my transmitter section. This section is my receiver section. Along with these two sections, we are having one more additional thing in this radar system, that is the display unit. Because whatever parameters we are going to observe, we must be visualize those parameters so that we can analyze and act accordingly. So in addition to the transmitter receiver section, we are having the additional visualization section or the indicator section. Okay, so let's discuss one by one. So as we are looking at the screen, and in the transmitter section there are three distinct blocks: timing unit, modulator and high power oscillator. So step by step we will discuss each individual function. So as we are discussing, it's a pulse radar. We need a basic pulse to be transmitted, and that pulse will travel in mode of electromagnetic signal towards the target or the object, far end object. It will be reflected back. So our prime object is to generate that pulse, process that pulse so that it can be transmitted for a long distance. Thereafter we can receive the echo and process it. So my timing unit generates that basic pulse. So this generates normally a rectangular pulse. So for that we can use any sort of rectangular pulse oscillator circuit. So that pulse generated is need to be transmitted for a very long distance. So this pulse is having a very small amplitude which cannot be transmitted for a long distance. So we need to process that prior sending to the far end. So for processing, at the first step we need the modulation process. So what is the modulation process? Here we generally use the pulse amplitude modulation, where we modulate this timing pulse with a sinusoidal signal. So in the pulse amplitude modulation, the output is somewhat like this. The sinusoidal signal multiplied with the pulse. So the sinusoidal signal is available for the pulse duration. So this modulator gives the modulated output which will be traveling for a long distance. Second requirement of this modulation is we need a very high frequency which is very difficult for us to produce. So we are translating the low frequency pulses to the high frequency pulse by this modulation process. Thereafter, for traveling through a long distance, it must be having a very high power level. So this modulated signal is further amplified by the high power amplifiers. So at this stage we generally use high power amplifiers such as magnetrons, Klystron oscillators, traveling wave tubes that we know from our previous knowledge. So these high power, high frequency pulses are now ready to be transmitted. So through this TR unit stands for transceiver unit. So as we are looking at this figure, we are having a single antenna for both transmission and reception purpose. So we need some specific arrangement so that the signal can be sent to the antenna from the transmitter without entering the receiver, because this transmission signal is a very high power signal. If it enters the receiver section, then definitely the receiver section will be burnt out. So to protect our receiver during the transmission phase, we need this TR unit, and through this TR unit, this high power, high frequency pulses are sent to the radar antenna, which is transmitted into the space. Thereafter, the echo signal received from the target is again acquired by this antenna, and this is transmitted through this TR unit to the receiver section. So as all of us are knowing, the receiver section is nothing but a simple super heterodyne structure. So super heterodyne receiver, what does it do? It first limits the received signal frequency, then it translates the frequency. So the limitation is done by the filter unit, followed by the translation of the signal is the job of mixer and local oscillator. So after passing down the signal through this mixer and interacting that received signal with the local oscillator signal frequency, we get the intermediate signal frequency. So that signal frequency is amplified. Thereafter a second detector stage which detects the actually target position. Then that signal is passed to the indicator section through this video amplifier. Again, here we need a small trick, because our transmission signal and the receiver signal, they must be synchronized. So how to synchronize both the transmitter and the receiver section? For that, we need to pass a channel from the transmitter to the receiver, which takes the timing unit signal, so that our common signal is taken as the reference for our indicator, and that timing unit signal is a rectangular pulse. So we need a sawtooth pulse to operate our indicators, because the sweep generated in the indicators require the sawtooth pulse. So those conversion from rectangular to sawtooth pulse is done by the sweep generators. So as we have shown in this small diagram, so I have only shown two type of indicators. One is the range indicator, second is the PPI. That PPI stands for plan position indicator. Basically PPI is a circular indicator which gives you a pictorial view of your target position in respect of its distance and its horizontal angular coordinates. So these two parameters we are observing on the PPI, and as shown in the range indicator, it gives a more accurate range, that is the distance of the target from the radar antenna. And simultaneously, here one more block is left, that is the antenna drive motor. Basically, in case of a pulse radar, we need to rotate the antenna 360-degree clockwise or anti-clockwise. So to do this operation, we need a drive motor. So at which speed the antenna is rotating, that we don't know. At which speed my sweep is rotating, we don't know. So there is a requirement to synchronize both the rotations, because if there is any deviation in the rotational speed of the antenna and the sweep, then there will be a mismatch in the bearing information. Bearing information is nothing but our information of angular position of the object with respect to the antenna, So we need to synchronize our antenna position and the PPI sweep position. So to achieve that, we transmit a synchronizing pulse from this antenna drive motor to this PPI. So my sweep is properly synchronized with the antenna position. That means if my antenna is looking towards east, definitely my sweep will be towards the east only. If my antenna is looking towards north, then my sweep will be towards north. I hope you are clear. Okay, next we will move towards the next segment. So next segment is the application areas of pulse radar. So as we have seen here, the pulse radar transmits the signal from the antenna to the target in terms of short range, square or rectangular pulses. So these pulses are traveling through the space. It needs some time to reach out the target. Then the target reflects back the echo, and the echo is received by the antenna. So this time gap of traveling from the antenna to the target and the target to the antenna back. So this time gap is calculated, and we know in the physics that EM wave travels in space with the speed of light, and with the relation between V, that is the speed of light, and time of flight, we can calculate the target distance very easily. And as we are synchronizing the antenna direction and the sweep direction, from that parameter we can check out the target positional value, that is the bearing information, and as well as in some cases if we are using the third coordinate, then we can also measure the elevation coordinate. So these type of antennas or systems are giving us range information, bearing information, and elevation information. So these three are the main criteria to find the exact position of any object in this three-dimensional space. So this pulse radar is able to give us all the parameters which is essential to detect the object and, if required, track the object. So this is the radar we are using mostly in the military area, where we need to detect our enemy, destroy their missiles, destroy their firearms, destroy their troops. So this is the most vital antenna system or the radar system which is used nowadays for every sort of applications where exact monitoring and control is required. So thank you all. This session is over.